Next, we have Dr. Alamgir Naushad. Dr. Alamgir Naushad is an assistant professor at NUST, specializing in communication networks, UAV systems, and lot technologies. His research focuses on wireless communication, satellite systems, and smart network solutions. He has published in leading international journals and has been actively involved in global research collaborations. Please welcome Dr. Alamgir Naushad. After this session, we will have a lunch break. The attendance Google form and group link for certificate will be shared. After the lunch break, we will resume our session. Please participant, stay tuned to us. And now over to you, sir, Dr. Alamgir Naushad.
Am I audible, please?
Yes, sir.
Okay, so is my screen visible?
Yes, sir.
Okay, so I am Alamgir Naushad. Just briefly introduce myself. I completed my PhD from Ghulam Ishaq Khan Institute of Engineering Sciences in collaboration with the Harriet Watt University UK for my research. After that, I joined NUST Balochistan campus, where I remained head of the computer science department for 3 years. Last year, I joined College of Aeronautical Engineering in the Department of Avionics Engineering, where we worked on various projects related to the CubeSats, satellite communication, and UAVs. Recently, I have joined the Institute of Applied and Engineering Physics in Mohammed VI University, Morocco. So before going through my presentation, I would like to congratulate the entire organizing team for arranging such a wonderful conference, and the title in itself, it's very appealing. So it's a big success. The organizing team, they have worked hard. So it's really a great uh, show, and I think we need to have much more for collaborations and understanding of the science and technology, where there are um, uh, interdisciplinary research paradigms. So I think I have 30 minutes, so I will not be able to explain in much detail. I just want you guys to have the insight of some of the key research areas that I'm working on. The first one is the communication systems. The second one is radar and localization. The third one is the security, having secure operations for drones and smart grid systems. The fourth one is sensing and IoT, Internet of Things. And the fifth one is biosensing and health monitoring. So let's start from the first one, that is the communication systems and radar and localization. So I'll introduce 5G and 6G, then I'll discuss intelligent wireless innovation, then significance of link stability in communication networks, and then intelligent network automation, a key concept that is very, very important for 5G and 6G. And then I'll discuss some of the relevant research projects. So why 5G is important? So there are some of the driven factors, but the key factor is that it provides a coverage that is almost 100%, and the availability of the service that is about 99.9%, and more importantly, the latency is about like 1 millisecond. So whenever there is a link disruption, so it has to restore the link connectivity in less than a millisecond of time. Here are some of the emerging use cases for 6G networks. So you can have many applications if you go from 5G to 6G, so the entire perspective changes. So here you can have the applications in remote healthcare. Like recently, you must have heard one of the surgeon, he operated a surgery from Australia, miles away, sitting in the other continent, and the patient he was operated through online surgery platform. So this is a big innovation. Then we have the industrial automation, where we talk about the industry 4.0. Then the precision agriculture, like the UAVs and drones, we can employ them for precision agriculture. In addition, we can have the applications in disaster management and the topography of the Earth's terrain, like having the 3D reconstruction of the areas which are not easily accessible through our other means. Moreover, space connectivity. Now, this is again a very interesting aspect of 6G, how we can have the connectivity of drones or UAVs or the satellites for better interoperability of the different applications. So here you can see there are a lot of applications for 6G system, and autonomous vehicles, again, it's a very important aspect. So now there are three key driven factors for the 5G connectivity. So here I just wanted to let you know, guys, that there are 5G connectivity, and we have the concept of Internet of Things and AI. So these three in combination, they provide a very innovation platform. So we can call it intelligent wireless innovation. So actually you are employing 5G connectivity with the Internet of Things, smart connectivity, each and every operation almost autonomous and connected. And then you improve, you innovate through the addition of AI in it. Now I'll discuss the importance of link connectivity in communication networks. So actually link connectivity is very, very important. So depending upon the application, the link should be reversed. It should be reversed to the failures. But whenever there is a failure in the link, so we need to restore it as soon as possible in order to avoid the disruptions in the data and in the applications. So now why enhanced connectivity is important. So UAV assisted communication networks. So actually for drones to be connected to different devices, including sensors, cameras, GPS, and other drones, we need the UAV assisted communication networks. This enhanced connectivity enable drones to work together more effectively. So actually, there is two types of communications are very important. The first one is the internal communication between the different devices within the drone, and the second type of communication is the communication between the drone and the ground station. So both of these communications play a very pivotal role, like the intercommunication between different devices on the drone and the communication with the ground station. So they should work together more effectively for sharing data and communicate with each other in real time. Now I'll discuss some relevant research projects. I will just quickly go through it. This is one of the research projects where I proposed the intelligent decision support systems. So for wireless emergency alert system using agent-based peer-to-peer coordination framework. So this is the architecture where we proposed how we can clarify how we can employ our network as an intelligent decision support systems. So actually, if you see, there are different zones, and these zones generate event reports in case of any emergency, and those alarms are processed by the emergency processing units, and then it creates emergency alarms, and then there is an evacuation center which inform the other applications to be initiated for addressing the nature and severity of alarms. This was the other application, IoT-based smart agriculture monitoring sensing systems. So here in this, we employ this, we worked on the UAVs, which was connected with the satellites for the position and coordination of the different cluster heads. And then we have the data interpretation, like we have the ground station, and the ground station, there is a two-way communication with the UAVs. And again, the UAV is connected with the different cluster heads with the different nodes. And then they are communicating continuously with the satellites. So again, we employ this IoT-based smart agriculture monitoring system for sensing applications on the field. Now, there was a very key concept like how the trajectory planning can be obtained at different locations. So actually there are different nodes, and if you see, whenever the drone or the UAV that is changing its coordinates, so with the change in coordinates, if you see the blue dots and the red dots, it represents the cluster heads and the other nodes, so how they are changing the positions. But whenever they change the position, we should be able to achieve the connectivity at every time step. So actually we employ the continuous time Markov chain for prediction of the position and localization of the UAV at the next time step. So for that, if you see, I performed the analysis and run a simulation. On the left-hand side in the figure, you see the blue is the cluster head, and the red node is the node on the ground. So if you see, and the white nodes, they are the other nodes. So if you see, there is a connectivity. You see at different locations, the connectivity remains intact. So this is very, very important. So we need to ensure the connectivity between the cluster head and UAV randomized locations. So UAV can change its position randomly. You see, so with the change in position, the connectivity should be ensured. So this was the initial result for the 5-path generation connecting the randomized locations. This was the simulations. If you see again, we are achieving the connectivity. If you see the dots, the black dots, they are connected, and the right side of the figure, there is a improved coverage. We also improve the coverage through the use of the optimization cases and the antenna. The antenna that we use, we improve the coverage through UAVs and trajectory generation. We also conducted some of the research in the Python for the Phantom 4. So I have some of the code, but I will just skip. If any student in future, or if anyone is interested to collaborate, I'm happy to collaborate. This was some of the images from the Python where how we can model this connectivity. So actually, I just skipped through it. Now, there are some challenges in designing drone-to-drone communication. So what are the challenges? The challenges are many. Like we need to ensure the seamless connectivity. There should be scalability. Like if there are more drones that are added to the network, the operations should be seamless. The performance should not be disrupted. Moreover, if there is a link failure, as I discussed, we need to recover from the failure as soon as possible. And then we also need to analyze the entire network behavior, like how the entire network is behaving, because the resources, the bandwidth, and the resource allocation algorithms, they've worked independently on every node or uh, uh, on every node or router. So actually, we need to ensure address all those challenges. So for that, we come up with the idea that that this entire process of UAV's communication is a very resource intensive. So for that, we propose the edge native optimization of UAV communication. So actually, we need to process the different applications or the different processing at the edges to optimize our resources other than doing it independently. So I also presented one of the research projects, that is the design and analysis of the link state uh, proactive connectivity model to enable UAV communication architecture for exploiting the opportunity of drones distributed processing applications. So this is again one of the key area where I'm open to collaboration and I'm open to guide you people if you want my help in that. These were some of the assessed contribution with reference to the functional blocks of UAVs. So there were different parameters like the flying capability, how we can incorporate the functionality of sensor and actuators at the contribution level of mobility management. Then the wireless communication. For that, we need to propose a proactive model uh, that should ensure the connectivity. Then the storage and processing. For that, the contribution block is quality of service, operational control, and different operations, where we require the distributed processing capability and the traffic management. So here we have the breadth and the contribution blocks. So while addressing the challenges in drone-to-drone communication, we come up with the integration of core modules while designing drone-to-drone communication protocol. So these are, you see, these are some of the function blocks which are very, very important. So I will not go through the detail, but I will just discuss the key blocks at different modules. So this is the protocol that I propose, the link state proactive routing protocol. So here we have the mobility management. We need to take into account the mobility management, heterogeneity of links for ensuring link stability metrics, then the heterogeneity of nodes, link efficiency, path duration statistics in terms of throughput, overhead, cluster stability, traffic management in the network, link reliability, how we can achieve reliability of a link in the network. The next one is handling the dynamic topology. The other one is the quality of service routing, and the final and most important one is the faster failure detection. So here you need to know the key difference between the faster failure detection and faster failure prediction. So detection is a reactive strategy. So whenever there is a failure, so you will react. Whereas the prediction, faster failure prediction, it's a proactive strategy. So you detect the failures or by calculating the probabilities of the link connectivity and disconnectivity. So it depends on many factors like the range of the cluster head, the communication efficiency of a node, or the response time of a node. So from all those factors, you can calculate the prediction efficiency, the link, the probability of connectivity of a link at the future time step. So that is again a very, very interesting application, like for disaster management or precision agriculture or space connectivity. Here in my current university in Morocco, we are working on the prediction of clock with the satellite. So actually, there are some of the databases uploaded by the NASA where you have the ground stations and there are different satellites in the space, the LEO satellites, where they are continuously transmitting the data, and the data is actually processed by the ground stations. But you know, the LEO satellites, the low Earth orbital satellite, it is moving at a very high speed, like 8 kilometers per second. So actually, there is a very short window of receiving the data, plus the clock, the internal clock of the satellite, there are factors like the clock drifting, drifting in the clock, or the relativistic effects due to high speed. So actually, we need to synchronize the clock at the satellite and the clock here at the ground station. So again, I am working on that project as well here. So that is again a very important aspect. This was the second area. Do I have time? How much time do I left so that I can manage accordingly as per the. Sorry, how much time do I left? Should I continue?
3 minutes, sir.
3 minutes. Sorry, you are not audible. Can you again sound how much time is left?
3 minutes, sir.
Okay. So I will quickly go through it. 3 minutes. Okay. I will share the presentation with you guys as well through the organizing team, but I will just quickly go through his slides. This is like the cyber physical systems, the industrial revolution for industry 4.0. So here we discuss about, just quickly go through it, the introduction to the cyber physical systems. So there are different revolutions, first, second, third, and fourth industrial revolutions. In the fourth revolution, we discuss the cyber physical system, AI and IoT, big data, and edge computing. So there were some technologies and outcomes of industry 4.0. You see, we discuss about the globalization and complex product development, certain drivers which enable why this technology is enabled. So there are certain drivers, and then there are outcomes of those, like the predictive systems, computation-based business models, asset digital twins. So there's no time, so I'll just quickly go through it. If any one of you are interested, I can have a separate meeting for discussing any project related to your interest, if you feel you can have interest in these things. So this is again industry next. Okay. Then there are some of my research projects, some of my papers relevant to this. So I'll just quickly go through it. Some of the papers. Here we discuss about the attack success probability, how we can calculate attack, the success probability of the attack on the network. Okay, just quickly go through it. These are some of my papers. Okay. Actually, 30 minutes is not enough. You can just discuss a few things, but anyhow, this was the final biosensing and health monitoring. So actually, I will discuss very briefly the EIT. So electrical impedance tomography. So again, this is a very promising technique. In my master's, I worked on this. So I reconstructed the target through dynamic images using the extended Kalman filter. So actually, if there is a tumor or there's a tumor, so actually the procedure of biopsy, it's very painful. So actually, what we do in this technique is that we calculate it on the basis of the current. There is a voltage belt. There is a belt. If you see this belt having 16 nodes, and a very few milliampere current is injected at every node to calculate or to reconstruct the image. So this is a non-invasive technique. So actually, this is again, I'll just quickly go through it. We selected different targets on the region using the finite element method or mesh structure, and then we use the case scenario for static imaging and dynamic imaging. So to determine the location, exact location of the tumor in lungs. Then we evolve the target, true evolution of the dynamic target at the corners. So again, then there was point spread function, certain parameters to calculate the performance figure of merits of the target. So there were different responses like amplitude response, resolution, standard deviation, position error, ringing, and weighted spatial variance. These were some of the results for the evolution of the target. And these were some of the scientific considerations to digital health system, like the diagnostic aids, quality of improvement, quality assessment, and remote monitoring. Okay, these are the Industry 4.0 future research direction. If anyone is interested, so we can discuss the projects, a few projects related to the Industry 4.0 in machine learning, big data analytics, and cloud computing, cyber physical systems, augmented reality, cyber security. Some of my articles were published, and thank you so much for listening. Yes, thank you. If there are any questions, you're welcome to answer the questions. So I will share my email address in the chat. If you want to collaborate or discuss any potential projects, I'll provide my help anytime. You're most welcome. So actually, Pakistan, you are in the university and you are students, so you are our future. And I would be happy to contribute, like whatever knowledge I can contribute, I would contribute it for the. Okay, so I am mentioning my email. This is my email. You can reach out to me if there is any question. So please, you may ask. I just yes. Sorry.
For your engaging and insightful presentation. Thank you so much for your time. Your work represents the future of smart communication and technological innovation. Thank you so much, sir, for your
Yes.
valuable
Just
time.
thank you so. Thank you so much for inviting me to the conference. And I just want to to complete my presentation by just giving you a food for thought. Actually, we have a lot of conferences, seminars, we publish the articles, we but the outcome is not productive. So what I feel is that, like, we are not engaging the strengths of our researchers and the students at the abstract level. So actually, there has to be some reforms at the very abstract level, like to engage them, to give them confidence, and to engage them in a good working environment. So actually, I'm looking to, like, whatever I can do, like at my level, I'm looking to reframe such ideas at the abstract level. So actually, if we do this, we can have a very productive outcomes from our students, because Pakistan and its students, they are brilliant. They can do wonders, but they just need to be on the right track. So this is what I had to say. Thank you so much for giving me the opportunity to present my work and for giving me some of the insights for future.
Now I would like to invite Dr. Ashraf Al-Ghanusi. Dr. Al-Ghanusi is an associate professor at the Faculty of Pharmacy, Mansoura University, Egypt, and a former postdoctoral fellow at the Korea Institute of Science and Technology. South Korea. With over 15 years of experience and more than 30 high-impact publications, he has made significant contributions to medicinal chemistry and drug discovery, focusing on translating molecular research into real-world therapeutic solutions. Please welcome Dr. Ashraf Al-Damza. Please, sir. Over to you, sir. Can you hear me, sir? Dr. Ashraf Al-Damza. Can you hear me, sir? I think, sir, you have some problem. Please wait, participants. Dr. Ashraf Al-Damza has made significant contributions to drug discovery and development. His research involves extensive interdisciplinary collaborations across Egypt, South Korea, and the broader MENA region, reflecting his strong commitment to global scientific progress. Sir, can you hear me? Participants, please wait. Dear participants, please wait. Events like this are essential for bridging the gap between research and real-world applications, promote scientific innovations and interdisciplinary research, encourage young researchers and emerging scientists, strengthen global academic and research collaborations, provide solutions to challenges in health, environment technology, and sustainability.
Dear participants, can you hear me? We will now take a lunch break. We request all participants to please return to the session after 10 minutes. The meeting link our speaker, Laura D. Clemenza, she is available. Now we move back to Laura D. Clemenza.
Yes, I'm here.
Thank you, ma'am. Now I will invite